we're going to do question 4. We are given a linear pattern of 5, 7, and 9. In 4.1, we are asked to determine the term number 51 of this linear number pattern, right? So it's a linear number pattern of 5, 7, and 9. Firstly, we're just going to find the difference of this pattern here, and we found to be 2. So it tells us this linear is actually an arithmetic sequence, right? Yes, a linear number pattern is an arithmetic sequence. We've proven that by finding the common difference, right? So now, because we want to find t of 51, we need to first find the general term or the general formula of this arithmetic sequence, right? So we're going to say Tn is equals to a plus into n minus 1 multiplied by d. So this is the general formula of an arithmetic sequence, and we want T51. So what is the a value? The a value is 5. It's going to write 5 plus into the term is 51 minus 1, and the difference is 2. So T of 51 should give us an answer of 105 if you punch this into your calculator. So that is the answer of this problem here. So going to 4.2, we are asked to calculate the sum of the first 51 terms. So knowing very well that this is an arithmetic sequence, our sequence is 5, 7, and 9, right? And we know that our a value is equals to 5, our difference, common difference, is equals to 2, and we're asked to find the number of terms, the number of 51 terms, right? The sum of 51 terms, and we know that this is an arithmetic sequence, right? So you're just going to use the arithmetic sequence formula, which is given by sum is equals to n over 2 into 2a plus into n minus 1 multiplied by d, right? So I want the sum of 51 terms, so it's going to be 51 divided by 2 into 2, or multiplied by 5 plus into 51 minus 1 multiplied by difference, which is 2, right? So you're just going to punch this into your calculator, and you're supposed to get 2805 as your sum of 51 terms. So now we're going to 4.3, where we are told write down the expansion of this here. Show only the first 3 terms and the last term of the expansion, right? So we are asked to just identify the first 3 terms, right? Obviously we need to identify term number 1, term number 2, and term number 3, and then the last term, so the last term of the sequence. So this is T1, T2, and T3, right? And then T last. So these are the terms that we need to identify, right? The first 3 terms and the last term of the expansion. So for us to do that, we are given the sum to, at the top is 5,000, right? N is equals to 1, and this is 2n plus 3, right? So to find the first 3 terms, we're going to say n equals to 1. We're going to substitute that 1 into this equation here, so it's going to be 2 into 1 plus 3, and we're going to get 5. So when n is equals to 2, 2 into 2 plus 3 is going to give us 7, and when n is equals to 3, 2 into 3 plus 3 is going to give us 9. So these are the first 3 terms. So these are the first 3 terms. Now we want to identify the last term, right? So to find the last term, n must be equals to what? 5,000, right? That is 5,000 is going to be our last term, so it's going to be 5,000. So we're going to substitute 2 into 5,000 plus 3, right? So which 2 times 5,000 is 10,000 plus the 3, so you're gonna get 10,003. So this would be the answer. So the first 3 terms and the last term, we're having 5, 7, 9, and the last term being 10003. So that is the answer for this question here. So now 4.4 says that hence or otherwise calculate this value here, right? So you need to calculate this value here, the sum of this, and add it with the sum of this, right? So we can simply just do these sums individually, right? We're having a sum of 5,000, which is the top value, n is equals to 1, right? And an equation of 2n plus 3, and this sum is added with the sum of 4999, starting at n equals to 1 minus 2n minus 2n minus 1. Right, so this is the sum. So we can just calculate each sum individually and just add both, right? So what you're going to do is this: you're going to say, okay, find the sum of 5,000 at the top, n equals to 1 of 2n plus 3, right? So for this one here, we know very well that n, when n is equals to 1, so it's going to be 2, 1 plus 3, giving us 5. When n equals to 2, 2 into 2 plus 3 equals to 7. When n equals to 3, so it's 2 into 3 plus 3 equals to 9. So this, if you remember clearly, it's from the previous question that we found. It's going to be 5, 7, and 9. So that is our sequence. And to find the sum for this sequence, we know the difference here is equals to 2. So that's our common difference. So, and the number of terms is n being equals to top minus bottom plus 1. So the top is this 5,000 here, bottom is this one, and then you just add 1. So the number of terms is going to be 5,000 minus 1 plus 1, so it's definitely 5,000. So to find the sum, so you're just going to say the sum as n is equals to n over 2 into 2a plus into n minus 1 multiplied by d, right? And we want the sum of how many terms? 5,000 terms. So it's going to be 5,000 divided by 2 into 2. Our a value is 5. It's going to be 5 plus into 5,000 minus 1. 5,000 minus 1, close bracket, multiplied by our common difference of 2, close bracket, and you should punch this into the calculator and you'll get a value of 25020,000. Right, so you're having a 25,020,000. So that is the sum of this expression here, right? This one here. So now we're going to find the sum of this one here and then add both together. So for us to find that sum, we're just going to write sum of 4999 when n is equals to 1. It's minus 2n minus 1. So when n is equals to 1, to find the first 3 terms, right? So we're just going to say minus 2 into 1 minus 1. So the first term is minus 3. When n is equals to 2, minus 2 into 2 minus 1. And another term is 5. So when n is equals to 3, minus 2 into 3 minus 1, you're just going to get minus 7. So these are your 3 terms. So you have minus 3, minus 5, minus 7. So these are the 3 terms of this sum here. So now we need to find the common difference between these two. So minus 5 minus minus 3, you're going to get minus 2. So the common difference is minus 2. And the n value is equal to top minus bottom plus 1. Top is this 499, so it's going to be 4999 minus the bottom, which is 1, plus 1. So your n value is equal to 4999, right? So you have your a value, you have your d value, you have your, so a value is equals to this minus 3 here, right? So it's going to be minus 3. Our d is equals to minus 2, and our n is equals to 4999. So you can find the sum. So it's going to be Sn is equals to n over 2 into 2a plus into n minus 1 multiplied by d. So the sum of 4999 is equal to 4999 divided by 2 into 2. Our a value is minus 3 plus into 4999 minus 1. Our common difference is minus 2. Let me write it nicely here. So common difference is minus 2. And the answer that we need to get here is equals to minus 24999,999. So this is the sum of this problem here. So remember that we had an expression and we asked to calculate the sum of 5,000 on top there, n is equals to 1, having 2n plus 3, plus the sum of 4999, n equals to 1, of minus 2n minus 1, right? And excuse me, and the sum that we found for the first expression here, we found the sum of 25020,000, and plus the sum of the second expression we found to be minus 24999,999, right? So you're just going to add both sums and you will get the answer of 20,001. So this would be your final answer of this expression here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.